Hey everyone, welcome back to the course. I hope you found part one helpful. Before we start, don't forget to like the video and subscribe to the channel. Now, let's begin part two with the third type of exam question for chapter one. Two charges are arranged as shown. Particle 1 has a charge of plus 4e and is located at a height of 2 millimeters. And particle 2 has a charge of plus 6e on the x-axis, 6 millimeters away horizontally. We are asked to find the components of the force, its vector form, and its magnitude. Let's solve step by step. First, we calculate the distance between the two charges using the Pythagorean theorem. This gives us r equals 6.32 millimeters. Next, we calculate the force F21 using Coulomb's law. Here, remember that the elementary charge E is equal to 1.6 times 10 to the power of minus 19 coulombs. Substituting the values, we get F21 approximately equal to 1.38 times 10 to the power of minus 20 newtons. Now, for the components, we use the angle theta, which is the angle between the force and the horizontal axis. From the geometry, cosine theta equals d2 over r, and sine theta equals d1 over r. So we write fx equals f21 cosine theta, and fy equals minus f21 sine theta. Substituting the values, we get fx equals 1.31 times 10 to the power of minus 20, and fy equals minus 4.36 times 10 to the power of minus 21. Now, we write the force in vector form. Finally, we calculate the magnitude using the square root of fx squared plus fy squared. All right, now let's move on to the next type of exam problems. All right, let's move on to another important exam type problem. In this question, 4 charges are placed at the corners of a square, and we are asked to find the net force components on particle 3. Let's start with step 1, calculating the magnitudes of the forces. Particle 3 is affected by 3 forces from the other charges. First, force F31. This force acts along the y-axis and is attractive. Using Coulomb's law and substituting the values, we get 0.072 newtons. Next, force F34. This force acts along the x-axis and is also attractive. After substitution, we get 0.144 newtons. Finally, force F32. This force acts along the diagonal of the square at an angle of 45 degrees. Using the diagonal distance, we calculate the force and get 0.036 newtons. Now that we have all the force magnitudes, in the next step, we will resolve the components and find the net force. Now let's continue and resolve the diagonal force. We break F32 into its x and y components using cosine and sine of 45 degrees. So F32x equals 0.036 multiplied by 0.707, which gives 0.025 newtons. Similarly, F32y is also 0.025 newtons. Now, let's calculate the net force components. In the x direction, both forces are positive, so we add them. F net x equals 0.144 plus 0.025, which gives 0.169 newtons. In the y direction, F31 is negative and F32y is positive. So F net y equals minus 0.072 plus 0.025, which gives minus 0.047 newtons. Finally, we write the net force in vector form. This is the final answer. All right, let's solve a classic equilibrium problem. We are asked to find the distance d such that the net force on particle 1 is 0. First, let's carefully look at the geometry of the system. The distance between particle 1 and particle 2 is d plus d. Also, using the angle, the distance from particle 1 to particles 3 and 4 is d divided by cosine theta. Now let's use symmetry. Here we focus on the forces acting on particle 1 due to the other charges. Note that the equilibrium condition, meaning zero net force, is independent of the sign of charge Q1. However, for drawing and visualizing the force directions, we assume that Q1 is positive. If we had assumed it to be negative, the final result would still remain consistent. The forces from particles 3 and 4 have equal magnitude because the charges are equal and their distances from particle 1 are the same. Their vertical components cancel each other and only the horizontal components remain. So we only need to focus on the x direction. Now we write the force balance in the x direction. The force from particle 2 must be equal to twice the horizontal component of the force from particle 3. So we write F12 equals 2 times F13 cosine theta. Next, we apply Coulomb's law and substitute the expressions for each force. Great. Now we are ready to simplify and solve in the next step. Now let's simplify the equation and solve for d. We cancel the common terms, including k and q1. Then we rearrange the equation to isolate d plus d squared. After substituting the numerical values, we solve the equation step by step. Finally, we get d approximately equal to 1.93 centimeters. And that's our final answer. All right, guys, this part is done. I hope you found it clear and helpful. Don't forget to like the video and subscribe to the channel. We'll continue the course in the next video.